Hello everyone. This is a presentation for Urdu to Punjabi machine translation system. This system is developed to translate Urdu Unicode text to Punjabi Unicode text. This system is developed in the C# language on the Windows platform. So we are not using any of the predefined tools. Every line of code we have written by ourselves from the scratch. To understand the working of this system, first try to understand the flow of this system from this diagram. This Urdu to Punjabi machine translation system consists of various submodules as shown in this diagram. The system take Urdu input text and check against the various subsystems. For example, in this machine translation system, we have created different submodules to refine the input text and generate the optimized output. For example, to handle the unknown words, we have various levels of submodules. For example, to remove the diacritical marks, and we have a module to check the ijafat words. We have a module for the stemming. We are also creating the inflections and checking against the knowledge base. Along with this, in the end, we are using the transliteration module. All the unknown words get transliterated to the Punjabi output text by using this module. All these submodules are based on various morphological rules and supported by the knowledge base. For the translation model, we are not using any predefined tools. As we know that the Punjabi and Urdu languages are closely related languages. Both languages share the identical grammatical structure as well as the same word order. To learn the translation model, we have manually mapped phrases and in place of IBM models. Obviously, the IBM models provide an elegant solution for the automatically mapped source and target language phrases, but for that we need a large parallel corpus to train the model. And we also know that the Urdu and Punjabi languages are resource poor languages. Therefore, we have created some simple and efficient solution to train this process, to train the model. The system takes the manual mapped phrases as a training file and calculate the translation probabilities as well as the language model based on that input files. The language model is responsible for generating the natural language. The system has been used the Nesker and a smoothing algorithm to generate the language model. For the decoding purpose, we have used the hidden Markov model along with the Viterbi algorithm. So for the training, we have Urdu Punjabi parallel phrases which has been generated manually, and along with this we have a Punjabi monolingual text. We required both things to generate the final output. First of all, we need to train the system, and we have created the two modules for the training part. One is to learn the language model and one is to learn the translation probabilities. And finally, we use the decoding process based on the Viterbi algorithm to generate the final output. Along with this, we are using various submodules as we have discussed earlier to support the final output. In this machine translation system, we have also used the text classification system to classify the input Urdu text. The most of the machine translation system, basically the statistical or as well as the neural machine translation system, use a single phrase table to translate the text. Instead of the single phrase table, the system used 5 different phrase tables for each domain. And the system has been trained on political, health, entertainment, tourism, sports domain. After the tokenization process, the text classification needs to classify the input text into the most probable class. Then the translation module use specific domain phrase table to translate the input text. By using this, we are also refining the output, and we are also cutting the search space of the system. So this is the diagram of a complete training and the translation system, where we have shown that we are putting the one by one Urdu monolingual text into the system, and the translation process generating some parallel phrase training files, and it contain obviously many unknown words that we need to check manually and translate them into the target language. And we are again providing this into the systems repository. From that, the training process generate the language model as well as the translation files, and that translated model and that trained model we are again using to translate the further documents, and this process goes on for the each and every document, and by the time the system get trained for the new document and refine itself with the new knowledge base and the training data. This is a sample of a trained knowledge base of our system, where you can see that we have various phrases, bigram phrases, trigram phrases, unigram phrases, along with some probabilities, which has been calculated by the system, not manually. And for the language model, we have a different files. From that, we are generating the language model. This is an example of language model training file. These are the brackets to show the boundary of a phrase. Again, these are not marked manually but by the system. So system is quite intelligent to mark to identify the boundaries of each and every phrase based on the previous knowledge base. So we just need to check once in the manually that all the phrases are okay, and there is no source language word. If there is, and we need to just translate into the target language word manually and save it, and system get trained by these files to improve itself. This is the web-based tool available on this URL u2p.learnpunjabi.org, where you can check the output of this system. You just need to copy and paste the Urdu input Urdu text here, and click the translator button. It will generate the Punjabi Unicode text for you automatically based on the knowledge base we have provided to it. So this is quite simple and easy, and output is also very good as compared to any other Urdu to Punjabi translation system. Thank you.